Well, good morning, my Algebra students. Today, we're looking at factoring by using a GCF for greatest common factors with polynomials. Now, there's a lot of things to this lesson, so we're going to break it into two parts. Today is part one. Factoring is the opposite of the distributive property. We kind of looked at this yesterday or 2 days ago. On the fractions that we had, we divided off a number, and that's kind of what we're doing here. So again, distributive property is when I have a 2 on the outside of the parentheses, and parentheses always mean to multiply, and we multiply it to everybody in the family, and we end up with 2a plus 4. Well, this time, when we are factoring, we are reducing or dividing off something that they have in common. So they both have a factor of 2. So we can divide off the 2. So we are taking away, or I could say, not subtraction, it really is division, like we did yesterday. We're dividing off the 2 from the A, and we're dividing off the 2 from the 4. And this is called factoring by GCF, greatest common factor. Now notice I divided by 2 again on the 2A, and I divided by 2 on the 4. Okay, let's look at this. Let's find the greatest common factor of 4x squared minus 3x. Well, the numbers only have 1, right? But between x squared and 3x, they have 1x in common. So the greatest common factor is x. So we're going to go ahead and divide off an x from each. And we know that if we have x squared and we divide off an x, that's just subtraction, right? With exponents, it makes it so easy. And of course, I can check it by redistributing it to see if I did it right. And I did. So what would be the greatest common factor here? Well, between 5 and 10, it's 5. And between a squared and a, it's a. Right? So I'm going to divide off a 5a from both terms, leaving me a plus 2. Let's try another. If I have 8x to the third power minus 12x squared, what's the greatest common factor? Well, with 8 and 12, it's going to be 4. And the largest exponent they both have in common is x squared. So now I divide that off. And 8 divided by 4 is 2. And x to the third divided by x to the second is x. And the sign doesn't change. And then 12 divided by 4 is 3. And x squared divided by x squared is 1. And 1 times 3 is just 3. Go ahead and try these. If you're working at home, pause the video and then check your work. How did you do? All right, what about when we have a trinomial? A trinomial, can I still divide a GCF away from a trinomial? Well, of course, it doesn't matter how many terms I have, as long as I can find a greatest common factor. So let's look at our whole numbers. Let's see, we have 10y to the third, so that's 2 times 5, and then y times y times y. 20y squared is 2 times 2 times 5 times y. And then I have 5y is just 5y. So they all have 5 in common. And of course, I could be thinking this, you guys. I don't actually need to write it out. But if you need to write it out, then do it. They have 5 in common, and they have a y in common. So now I'm going to divide off 5y from every term. So I put the 5y on the outside. 10 divided by 5 is 2. And y to the third divided by y is y squared. Plus, the sign doesn't change. And then 20 divided by 5 is 4. And y squared divided by y is y minus. And then we have, if you think about it, negative 5y divided by 5y is just negative 1, right? But negative 5 divided by 5 is negative 1. And y divided by y is 1, which negative 1 times 1 is just 1. And again, you could check it by redistributing it. Now, what if I wanted to take out a negative 5y, just for fun? Just for fun. If I did that, then I would change things. If I'm dividing by negative 5, then it would be negative 2y squared minus 5y plus 1. But we'll talk more about that later. Let's try another. In this scenario, I have negative 12x minus 8x squared. Both are negative, so I want to factor out the negative because that's something that they have in common. So I have 2 times 2 times 3 times x, and as we know, 2 times 2 times 2 and x squared. Again, this is what you're thinking, right? They both have a 2, they both have another 2, or we could just say they both have 4 and an x. So I'm going to go ahead and factor out. The greatest common factor is 4x, but I want to include that negative in there. So I'm going to factor out negative 4x. So negative 12 divided by negative 4 is a positive 3. And x divided by x is 1. And then plus negative 8 divided by negative 4 is positive 2. And x squared divided by x is just x. Right? Again, I like to write them in standard form. It's a little better. And you can check it by redistributing it to see if you did it right. What about this one? What do they have in common? You're right, just 1, nothing, right? I mean, if I go ahead and list it all out, I see that the greatest common factor is 1, so it's not really factorable. What we say is it can't be factored further. It is already in its simplest form. Go ahead and try these. Pause the video and then we'll check them. Okay, on 1a, I can see that greatest common factor is b, so I factor out a b. On 1b, I see that they have nothing in common. It appears that 9 and 64 would have something in common, but they don't. And then C has a 2x squared in common. All right, you're going to be doing factoring out a greatest common factor, just 7-2 part 1 for the homework, and you can find that homework on learn@vcat.net. See you next time.